Right, question number 9, it reads as follows. They say to us, let me see. Okay, so let us start. So question number 9, it reads as follows. It says to us, the probability that South Africa will reach the finals in the 2027 Rugby World Cup, it is 0.35. And the probability that New Zealand will reach the final is 0.60. The probability that neither South Africa nor New Zealand will reach the final is 0.08. Now, the question wants us to, for 4 marks, it wants us to calculate the probability that only New Zealand will reach the finals. So now this is what is happening when it comes to questions like this. You're going to have to think of your events. You're going to have to think of the probabilities that are provided to us at this point in time. Now, how many number of events are we talking about in this problem? We are talking about 2 events. The first event will be South Africa, which is abbreviated as SA. The second event will be New Zealand, which is abbreviated as NZ or NZ. So they want us to calculate the probability that only New Zealand will reach the finals. So when questioned like this, I know some of learners get confused how to answer questions like this. So let me give you a hint on how to answer this kind of question. So immediately when you see this only, it really means that we have a Venn diagram. So you're going to have to draw up or open up your own Venn diagram based on the information provided to us, and make sure that your Venn diagram it is correctly constructed. So like I said, so this is what is happening. We're going to have to open up our Venn diagram by starting by opening up the sample space. So let's call this sample space S. Now, how many events I said we have? It's 2, SA and New Zealand. The other thing that needs to be taken into consideration is when you draw a Venn diagram, most definitely you're gonna present your events using the circles, right? But the question is, are my circles going to overlap, or my circles are going to be separated? That's the second question that you would want to ask yourself. So let's see from the statement, how do we see whether the circles they overlap or the circles they do not overlap? Now, here's the thing. When you add this probability of South Africa with the probability of the New Zealand, you would suppose to get 1 if the events, they complement each other. So when you talk about the complementary events, it's when I take the probability of one event, I add it to the probability of the other event. If I get 1, I know that the events complement each other and the events are separated from one another. Okay, so when I take probability of South Africa, which is 0.35, and I add to the probability of New Zealand, which is 0.60, I get 0.95. So that means there is a probability that is missing. Okay, so that means there is a probability that is missing. Let me do it again. There is a probability that is missing, so which is 0.05. So in this case, that means the events, they really do not complement each other, and the sum of the events, they do not actually add to 1. So in that case, that means our events, they're gonna overlap. We're gonna have an intersection between the 2 events. So this I will choose to be the event of SA, and this will be the New Zealand event. Now, remember, we for a fact that we have the intersection, but we do not know what is the probability of South Africa and New Zealand. In this case, we're going to take it to be any variable. You can say A, you can say Z, you can say X, you can choose any variable that you would want to work with. So normally we choose the standard variable, which is X. So the unknown probability between the intersection of these 2 events, we'll just choose X. We don't know what will be the probability between these 2. Now, the probability of SA is given to be 0.35. This is the probability of SA, not SA only. So now the whole circle its probability, it is 0.35. But this only portion, which is SA only, we're going to have to subtract the intersection. So that means the probability of SA only, it will be 0.35 minus X. Okay. Let me rewrite this correctly so that, let me rewrite it correctly so that you can all see it clearly. So the probability of, let me do it, it's going to be 0.35, okay, subtract X. I'll just write it over there. And therefore, what will be the probability of New Zealand? The probability of New Zealand, it is stated that it is 0.6. But for New Zealand only, remember, for only this portion, do you see where my pointer is? For only this portion, this is New Zealand only. New Zealand only. So that means to get the probability of New Zealand only, we're going to have to subtract the intersection. But the whole circle is probability, it's 0.60, and then we subtract the intersection. Therefore, this will be the probability of New Zealand only. And they said to us the probability that neither South Africa nor New Zealand will reach the final is 0.08. So 0.08, it is the probability of neither one of our events. So it's going to be inside of our sample space, which is 0.08. Now, this is a complete Venn diagram. Supposedly, when you add all of these values, you're supposed to get 1 to show that the whole sample space, it is complementary, it complements itself. So now, here they want us to calculate the probability that only New Zealand will reach the final. So that means, what do we want to calculate? We want to calculate this portion only of New Zealand, which is New Zealand only, which is given by 0.06 subtract X. So that means probability of New Zealand only, it will be given by, from our Venn diagram, 0.60 subtract X. So this is probability of New Zealand only in terms of X. So we're going to have to determine the value of X, and we substitute it, and then we get the probability of New Zealand only. But how are we going to get X? Now, this is what is happening. We're going to add all of these probabilities because, like I said, all of the probabilities in the sample space, they complement each other. So that means we're going to have to add all of these numerical values and equate it to 1. So that means we're going to have to say 0.35 subtract X, which is South Africa only, plus our X, which is the intersection, plus 0.60 subtract X, which is New Zealand only, plus everything in the sample space supposed to give us 1. We say sample space complement itself, hence why we equate everything to 1. So now we can see that this X and this X will cancel off, and then we're going to have only one X there. So it's just negative X. Now let us consider by adding and subtracting these numerical values. On my calculator, I'm just going to say 0.35 plus 0.6 plus 0.60 plus 0.08, and therefore I get positive 0.29, which is equals to 1. Okay, and therefore now this is what I am going to do. Let me confirm my calculations. It's going to be 0.35 plus 0.6 plus 0.08, and then I get my calculations here were mistaken. So that means here we actually get, I hope you guys also have your calculators by yourselves over there so that we can confirm the calculations. So my calculation here is actually 1.03 when I add this, and that. Now, I'm going to transpose X to the other side of the equation. It's going to be positive X. I transpose 1 to the other side of the equation. It's going to be negative 1. So that means in this case, my X will be 1 subtract 1.03 subtract 1 is going to be 0.03. So now we managed to get the intersection between South Africa and the New Zealand. This is the probability between So now what is the probability of New Zealand only? Now we go back to our equation. So that means the probability of New Zealand only will be equals to how much? We said it's 0.60, subtract our x in this case, which is 0.03. And therefore, the final answer to this question will be probability of the New Zealand only will be equals to how much? You're gonna say 0.6 subtract 0.6 subtract 0.03. Therefore, our final answer will be 0.57. This is how we answer this question. And I hope that was clear. Feel free to ask whenever you really do not understand how did we manage to tackle this question. So now we move to 9.2. Let me do this first. You can take your screenshot. You will refer to it later on if you didn't complete writing it. Or we can come back to it if maybe you have a question based on this question. And for 9.2, it reads as follows. It says to us, a picnic basket. You know what I love about this question paper? It has the Venn diagram section. It has the tree diagram section. And it has contingency table. It also has the probability that we know. You will see other questions. So 9.2, it reads as follows. It says to us, a picnic basket contains X apples and 8 bananas. A fruit is selected at random and eaten. So that means if you select a fruit, you will never take it back into a basket because you're gonna eat it, okay? But we'll talk about that. Thereafter, another fruit is selected at random and eaten. This is the second trial or the second event. Now, the probability of selecting 2 different fruits in any order, it does not matter. You started with apple and come with banana, or you start with banana and come with apple, does not matter. In the first 2 selection, it is given to be 48/95. Calculate the total number of apples in the basket. You know what? I love being visual so that everything can make sense. So now, say for an example, we have the bucket, right? We have the bucket. Now in this bucket, we're gonna pour fruits. We're gonna pour fruits into this bucket. So apparently we do not know exact number of apples. So they just denoted our X number of the number of apples to be X. So in this bucket, so that means we're gonna have X apples. I'll say A for apples, right? We have X apples. We don't know how many number of apples do we have, right? But we know in this bucket, how many numbers of bananas do we have? We have 8 bananas. I'll say B for bananas. We have 8 bananas in this basket. So it's simple. It's something that you can also relate to. You have a bucket with fruits, literally. 8 bananas, maybe 10 apples or 60 apples. We don't know how many apples are there. Just it's X. You see, it's a bucket of fruits. Okay. So this is what is happening. A fruit is selected at random and eaten. So that means for the first time, you're gonna come. For the first time, you're gonna come and select a fruit randomly. We don't know whether you're gonna choose a banana or you're gonna choose an apple. We really do not know. So first trial, you're gonna come and choose a fruit randomly. That's a probability. Probably you're gonna choose banana. Probably you're gonna choose an apple. That's a probability. We do not know. Okay, so a fruit is selected at random and eaten. So that means if you take one fruit, let's say for an example, you take banana, how many number of fruits have left now in the bucket? You subtract only 1, and therefore that will be your new total. If still you select your apple, let's say at first trial you select an apple, what's going to be happen with the total number of the fruits? The total number of the fruits will also decrease by 1 because you subtracted 1 and you ate it. You're not going to return it back into the bucket. You have already eaten it, right? You have already ate it. So that's the important part that you need to understand. Thereafter, another fruit is selected at random, meaning you come for the second time. You come for the second time again. You select a fruit. Okay, you select a fruit. So now what is the total number of the fruits in this bucket? It's X plus 8. It is the total number of the fruits in the buckets. But when you At the first trial, when you pick one fruit, what will be the total number? From the total number, which is x plus 8, we're going to have to subtract 1. And therefore, how much do we left with? It's going to be x plus 7, because 8 minus 1 is going to be 7. So this is a new total after selecting one fruit and eat it. And then now you have this number of what? You have this number of fruits, and then you come again, you do what? You select, second try, you select from this new total. The new total is this one. You select one fruit again, you're going to subtract 1 once more again. It's going to be x plus 6. This is a new total after the second try. If you continue for the third time, we're still minusing 1 and so forth. Okay, right. So now this is what is happening. They want us to calculate the number of apples in the basket, which is x. So we're gonna open up a tree diagram for this type of events. So now, if we open up a tree diagram, let me open my tree diagram over here. Let me. I think this is too much. Let me open up my tree diagram. So this will be my tree diagram, right? This will be my tree diagram. So this is what is happening here. I will choose the even outcome to be apple. And then here I will choose the even outcome to be the bananas. Okay. So remember, this is the first choice. Remember, here we have the basket, right? We have this basket over here. So in this basket, we're gonna choose, if maybe we want to choose an apple, we're gonna choose out of how many number of fruits. The total number of fruits, there are x plus 8. But now we're going to choose out of how many apples. We don't know number of apples. We're just going to write x apples because we really don't know how many number of apples we're going to choose from. But now let's say maybe instead of us choosing an apple, let's say on the first trial, we choose a banana. So what will be the total number of the fruits in the basket? It is still x plus 8. But now because we chose banana as our outcome on this side of our tree diagram, so we will be choosing banana out of how many bananas? Out of 8 bananas, you see? So this will be the first trial. But now remember, this is what is happening. This is what is happening. Say, for example, we chose an apple. If we choose an apple, how many apples are left now? So remember, we have x apple, but because we don't know the exact number of apples, we'll just say it's going to be how many apples are left now? It will be x subtract 1. So that means we took one apple and then we ate it. And therefore, we left with how many apples? We do not know if it's x minus 1 because it is true. If apples were 10, so what will be x 10 minus 1? It will be 9 because you chose one apple, right, from the first trial. And therefore, how many number of fruits are now there in the bucket? So remember, number of fruits is the total number of the fruits, irrespective whether it's apple or a banana. But because you eliminated one fruit and you ate it, now again you're still going to have to subtract 1 from the total. So that means here we're going to have x minus 7 because you're going to say x plus 8 subtract 1, as much as I showed you over there, that our new total, it will be x minus 7. Okay, and therefore this again will be an outcome of banana. Do you all understand? Now again, let's come here. This will be apple, and therefore this will be banana. Here we're gonna have an apple, and then here we're gonna have a banana. So now let's come here. Let's say again we chose an apple from the first choice. And then the second choice, maybe we choose banana. So how many bananas are left? Let's say firstly, you chose what? From the bucket, you chose an apple. You didn't touch number of the bananas. So the bananas will always remain as 8 because you didn't at first trial, you chose an apple, not banana. You will be choosing banana on the second trial. So you'll be choosing out of 8 bananas. But how many number of fruits are in the bucket? Remember, already you chose apple from the first trial. So this is the second trial. On the second trial, now you have a reduced number of fruits. So meaning the total number of fruits in the bucket will be x minus 7. Can we see that? And then here we still do the same thing. I do not have enough space over there. Not to confuse you, let me change my color so that you don't get confused by this. So again, let's come here. Let's say on the first trial, we chose banana from the bucket. On the second trial, maybe we want to choose an apple. But how many number of apples are there? Remember, apples, at first, you chose banana, not apple. So apple are still intact. We still have X number of apples for this second trial. But because you chose banana at first trial, so you reduced the total number of the fruits by 1. So that means here again, the total number of fruits of the 1. So here it's positive. Why am I saying X minus? It's supposed to be plus, sorry, okay? Because we subtracted 8. So how many number of fruits are now left in the bucket? It's going to be X plus 7. Remember, we subtract only 1 from 8. Going to say 8 subtract 1. It's going to be 7, even there. And therefore, now let's say from the first trial, we chose banana. The second try, you will still choose banana. So if you choose banana, so how many bananas are now left? Remember, from the first trial, you picked 1 banana from 8. Now you left with 7. Here, you ate it. And therefore, you left with 7 bananas. But what will be the total number of the fruits? It will be X plus 7 because you subtracted banana from the first trial and then you ate it. You didn't return it into the basket. Okay? All right. All right. So now they say to us, the probability of selecting 2 different fruits in any order in the first 2 selection, it's 48/95. So this is where we are interested. We really actually do not care about everything. We are interested over here and here. We are also interested over here. Let me show you. Interested over here and there, because these are different fruits. From the first trial, you choose apple. For the second trial, you choose banana. Here, let's say maybe from the first trial, you choose banana. Second trial, you choose an apple. These are different fruits in any order. It does not matter whether you started with apple and banana or you started with banana or apple. The probability of you choosing this apple and banana, irrespective first trial or second trial, the probability is obtained to be 48/95. That's what we know. So that means we really do not care about this and that. Okay, I was just showing you how to complete your Venn diagram. This is how you actually complete your Venn diagram. Okay, but the only interest is on these colors that I have just highlighted. So remember, probability of AB, probability of AB plus probability of BA, which is different fruits. It is actually how much they told us it is 48/95. This is what they told us over there. Now, using these probabilities, we will be able to determine the value of X because we know that the value of X is the number of apples in the basket. So hence why they say to us, calculate the total number of the apples in the basket, meaning we want to solve for X. So that X, it will be through this equation, through these probabilities. So what is the probability of AB? So probability of A to B, remember A here, it is X over X plus 8. Multiply by B here, it is 8 over, here it is 8 over X plus 7, which is equals, sorry, there's something I'm missing, plus, which color am I using? Plus probability of BA. So here it's B here it's 8 over X plus 8. It's going to be 8 over X plus 8, right? Multiply by probability of A. Probability of A in this case, probability of A in this case is going to be X over X plus 7. It's going to be X over X plus 7, which is most definitely equals to 48/95. Now there's an equation we can solve for X algebra. So now how are you going to solve for X in this equation? It's simple. We just multiply. X multiplied by 8, we're going to have 8x over here, and therefore this bracket multiplied by this bracket. You know what's happening. This bracket multiplied by this bracket, let me just write it as it is. It's x plus 8, x plus 7 plus, and then 8 multiplied by x over there is going to be 8x over x plus 8 multiplied by x plus 7, which is equals to 48 over 95. Now LCD is the same, so that means we can add the denominator. So let's add the numerator. Sorry, 8 plus 8 is going to give us 16, right? 16x over, we write the common, which is x plus 8, x plus 7, which is equals to 48 over 95. Now here we're going to have 16x over, so let me treat this bracket. So x multiplied by x is going to be x squared, and therefore x multiplied by 7 is going to be 7x. 8 multiplied by x is going to be 8x, and then 8 multiplied by 7 is going to be 56, which is equals to 48 over 95. So let me check some. 48 divided by 95, or it can be simplified. And therefore here we're going to have 16x over, here we're going to have x squared plus 7 plus 8 is going to be how much? It's supposed to give us 15. Where's my pen now? We're going to have, okay, we're going to have 15x plus 56, which is equals to 48 over 95. And therefore, let's cross multiply. So we're going to have 48x squared, 48 multiplied by 15, 48 multiplied by 15, we get 720, and then here we're going to have 720x, 48 multiplied by 56, 48 multiplied by 56, we get 2688 is equals to 95 multiplied by 16. 95 multiplied by 16, it's 1520. Now we have 48x squared. Here we have x, let's not forget that. So I'm going to transpose this one on the other side of the equation. So I'm going to say 1520 subtract 720, subtract 720, I get 800. So that means here we're going to have negative, sorry, we're going to have negative 800x plus 2688 is equals to 0. Okay, so now in order for us to solve this equation, we can simply use quadratic equation, because we can see that it's going to be a lot for us to factorize this. So that means we can simply use quadratic equation. So when you use a quadratic equation, your x here, the correct x that you're going to get over here, it's going to be 12. Okay, I don't want to waste time anymore. So the x value that you're going to get over here is going to be 12. So that means we're going to have 12 apples in the bag. Okay, so that means we're gonna have 12 apples in the bag. So when you complete this equation over here algebraically, you know how to use quadratic equation formula a, b, and c, and therefore you will see the answer that you're supposed to get over here is supposed to give you 12. So this is how we solve this question, which is question number 9.